Welcome to The Explainer. Today, I want you to put on your astrobiologist hat and join me. We're going to dive right into one of the most profound, unsettling mysteries in all of science. We're going to look up at the night sky and ask a really simple question that actually has a terrifyingly complex answer. Why are we entirely alone? We all cheer when a new rover lands on Mars, right? We scan the ice of distant moons, we point these massive radio telescopes out into the void, and we just desperately hope to find a signal. We've always been taught that finding alien life in our solar system would be the absolute greatest discovery in human history. But what if it isn't? What if finding life out there is actually the absolute worst news humanity could possibly receive? Okay, let's set the stage here by looking at the sheer mind-boggling scale of the observable universe. Look at that number. That is 300 sextillion. That's a 3 with 23 zeros. That's the estimated number of stars out there. In our Milky Way galaxy alone, we're talking hundreds of billions of stars. And scientists estimate there are literally trillions of planets positioned perfectly in habitable zones where liquid water, and therefore life, could exist. Statistically speaking, the universe should be absolutely teeming with advanced alien civilizations. But then, we hit this massive contradiction. Because despite all those billions of years and trillions of perfect habitable planets, the number of alien radio signals we've intercepted is zero. The number of galactic empires we've seen, zero. Alien megastructures or von Neumann probes, exactly zero. When we look out into the cosmos, we are met with total, terrifying silence. This jarring dissonance is famously known as the Fermi paradox. Back in 1950, the brilliant physicist Enrico Fermi was having lunch with some colleagues, chatting about the high probability of alien life, when it kind of hit him. He asked a very simple, profound question. Where is everybody? I mean, any civilization with just a modest amount of rocket technology could colonize the entire Milky Way in a few tens of millions of years. On a cosmic scale, that's a blink of an eye. So they should already be here. But they aren't. To solve this paradox, thinkers like Robin Hanson back in 1998 proposed a dark, deeply unsettling explanation known as the Great Filter. The theory goes like this. Somewhere along the evolutionary timeline, between dead matter and a sprawling, galaxy-spanning civilization, there is a wall. It's a biological or technological barrier that is almost impossibly hard to pass. This cosmic filter essentially wipes out 99.9% of all life forms before they can ever expand across the stars. Let's map this out. To get to where we are right now, Earth had to pass through a series of discrete, incredibly difficult evolutionary hurdles. Hansen laid these out. First, you need the right star system. Then, simple single-cell life actually has to emerge. After that, complex eukaryotic cells. Then the invention of sexual reproduction. Then multicellular life. Then tool-using animals with big brains. And finally, human civilization. Every single one of these jumps was a massive, statistically improbable wall that life on Earth somehow miraculously climbed over. And just how lucky were we to make all those jumps? Well, check out the 30% rule from a recent astrobiological analysis of Earth. It took us about 4.5 billion years to reach this exact point. But in about 1 billion years from now, the sun's increasing luminosity is going to make Earth completely uninhabitable. That means if the evolutionary process on our planet had proceeded just 30% slower, the expanding sun would have literally incinerated Earth before intelligent life ever even had a chance to emerge. Talk about a close call. We barely made it. So, the really crucial takeaway here is that the universe might not be empty at all. Life might be sparking into existence all the time. But the Great Filter ensures that this life almost never survives long enough to build a radio telescope, let alone a starship. In this view, the cosmos is essentially a silent graveyard of failed civilizations that hit the wall and just couldn't get over it. Which brings us to the ultimate existential question for humanity's survival. Where exactly is this Great Filter? There are really only two options. Either the filter is safely behind us, meaning we are the incredibly rare, wildly lucky survivors of an impossible biological lottery, or the Great Filter is still ahead of us, meaning simple life is totally common, but advanced civilizations inevitably hit a wall and destroy themselves. Now, obviously, we desperately want the filter to be behind us. And hey, there is some evidence it might be. Look at this number. It took 1.8 billion years for life on Earth just to upgrade from basic, simple cells to eukaryotic cells, the complex ones with a nucleus. That is nearly 2 billion years of evolutionary trial and error where absolutely nothing happened. That massive gap strongly suggests that this specific biological jump might have been an extraordinary freak coincidence, a massive filter that is, thankfully, safely in our biological past. But what if getting past those biological hurdles is actually quite common? Well, then the filter is ahead of us. It means every advanced species eventually hits a technological or social wall they simply cannot pass. And honestly, we are looking right down the barrel of potential future filters today. Things like mutually assured nuclear destruction, a runaway greenhouse climate collapse, or even the creation of uncontrollable artificial intelligence that eventually views its creators as a threat. And there's another possibility, a deeply unsettling sociological filter called the dark forest hypothesis. This was popularized by the sci-fi author Lou Cixin. It assumes that survival is the absolute primary need of any civilization. But because cosmic resources are finite and you can never truly know the intentions of an alien species, the only logical move when you discover another civilization is to launch a preemptive strike. In this terrifying scenario, the universe is a dark forest full of armed hunters. The reason we hear silence isn't because the universe is empty, it's because broadcasting your existence is a fatal mistake. So, to survive all this, we have to scale our civilizations safely. Researchers estimate that based on our current energy consumption trends, if we manage our resources, information, and population correctly, humanity is projected to reach Type 1 on the Kardashev scale by the year 2271. A Type 1 civilization is one that can harness all the energy of its home planet. But right now, we are navigating an incredibly volatile window. We're basically racing to become a multiplanetary species without triggering our own extinction, our own great filter, first. And as astrobiologists, when we look back at Earth's history, we realize our survival required a bizarre, almost comical string of catastrophes, like the collision with the protoplanet Theia. That created our moon and kick-started plate tectonics, which in turn gave us the chemical energy for abiogenesis, the creation of life from non-living matter. Even global extinction events like the end Permian or the asteroid that wiped out the dinosaurs, those were absolutely necessary to clear the way for mammals and eventually us. These incredibly rare, hyper-violent events suggest that our existence is just an absolute anomaly. And you guys, this is exactly why our search for biosignatures in the solar system is actually kind of terrifying. If our next rover digs into the Martian dirt and finds simple, extinct biological life, even just a few fossilized ancient bacteria, it would be terrible news. Why? Because if the spark of life happened independently twice, right here in our own tiny solar system backyard, it proves that the very first step of life is actually incredibly common across the universe. And it gets worse. If we send a probe to Jupiter's moon Europa, drill under that thick ice, and find complex fossils, like a multicellular organism or some kind of alien fish, it would be a crushing blow to humanity, because it would mean that life easily passes those early biological walls. And if life easily becomes complex, but we still see an entirely empty, silent galaxy around us, well, it pretty much guarantees that the great filter has not happened yet. It means the filter must be in our future, waiting in the dark to wipe us out, just like it wiped out everyone else. This whole idea is exactly why the philosopher Nick Bostrom famously wrote, "Dead rocks and lifeless sands would lift my spirit." When we look out at the other planets in our solar system, a completely sterile, lifeless void is actually the greatest possible indicator that the hardest evolutionary steps are already behind us. It means we have already survived the filter, and the entire wide-open galaxy is ours to peacefully explore. So the next time you step outside and look up at the silent night sky, realize that its emptiness might not be a tragedy at all. It might be a profound blessing. We might just be the very first to make it through the impossible cosmic lottery. Knowing all of this, knowing that finding aliens might actually seal our inevitable doom, what do you hope the next Mars rover finds?